And so I want to point this out because a lot of students get tripped up here and think we're moving or translating. We're not. Notice how B is how far away from the x-axis here?
Exactly
2 units. How far is it here?
2 units.
2 units. How far is A? It is 5 units, and to the other side, 5 units. When we reflect, we flip that figure over the line of reflection so that those points are the same distance away. Okay? So that's what's happening there. When we talk about that reflection, right? The figure is flipped over the line of reflection. You can get out a separate sheet of paper if you want. I got some free paper over here if you want it. I got it. Anybody else want some free paper? No. He hasn't written all the other stuff there, so he doesn't know. Oh, did you? Okay. The figure is flipped over the line of reflection, maintaining same distance from that line.
I feel like I need to be in a commercial.
Yeah. What commercial?
Cheeses.
No, you thought the hot dog came with cheese there, man.
Mickey, that thing said hot dog with cheese.
With cheesy.
On this. They
You
ain't say
love
cheese.
cheese. You love cheese.
Alright,
I ain't know how that was a man.
so we have a definition of what is a reflection, but what is causing that reflection? Okay, the change in the y value, but what's causing that change in the y value? Remember, it was only the change in the y value there. I can also change the x. Multiplication by a -1.
Can't see this.
You gotta be like
Your handwriting look different.
I'm sorry.
No offense, you know.
I'm not offended.
We used
It's
to have a
handwriting.
teacher that brought like elementary to high school, like an elementary student.
I used to have a bad hand.
And he talk
like that.
That's fine.
Be nice. So we want to notice that multiplying by -1 is what's causing those reflections.
What the word say? Sap? Same?
Same distance.
Oh, no, it's like a P.
Push P.
Same distance from that line. So I need you to notice both dilations and reflections come from what kind of operation? Multiplication. It's whether it's greater than 1 or between 0 and 1, whether it's a stretch or compression, and it's whether it's a negative if it's a reflection. And don't forget, division can always be rewritten as a what? Multiplication. They struggle.
Man, please get him, because I know he ain't know what I just thought he did.
No, they're my belt.
Don't play like that.
What happened?
Look, he just shorted.
Oh, you farted?
Look,
Oh,
my belt.
Pull your pants
Your crack something.
up. Yes.
probably, bro.
Alright. We got about 15 minutes left that we need to learn.
I know, Miss Kendall. Don't let it down.
Now you fair, Dad.
Miss Ken, I think my edit collaboration should be good today.
It's going pretty well right now.
I'm going great. We got 15 minutes left. Day about over.
I know, but we got a little bit they're going to work on in small groups, so you got to finish up there. Alright, so what we're trying to look at today is furthering our understanding of how a transformed function changes in relation to a parent function. So you got to recognize the parent function, and then identifying a rule for which a dilation and or a reflection is represented graphically, tabularly, or in an equation. And so we've already started talking about it. Remember, you want to come back to this, because has any of this been in relation to functions? No, this has all been in respect to geometry, triangles. But could this help us understand how it's operating inside of functions?
Yes, sir.
Yes. So, let's look at the Desmos activity. This is...
Okay, that's the one more time.
Alright, here is your code to get back into Desmos.
I got a headache.
Sorry, we got 15 minutes.
Yeah, let me show you what
Be
it's
like
like.
TikTok.
It is. You know that dark
I
skin?
tell you
Leave that out so I can take care of it.
Look,
Stop.
skin dude.
Student.desmos.com?
Yeah. I typed it up 2 times because I thought I was doing wrong with my extra.
You put demos, not Desmos.
You're
That makes a bit of a difference. Here you go.
Demo, you from
looking at the white just didn't look.
She playing up.
She had the name, man.
That was the issue.
Can you play Xbox?
Xbox during the summer we have time, but I need you to focus on.
We being active on that.
Come on, come on, you actually got to go to Desmos. You got to log in.
I'm going to log in.
No, we just used it yesterday.
You know I'm mad. I ain't used none yesterday.
Oh, you're right. You didn't even.
You know you told me for real.
Your mom asked, what was I supposed to do? Lie to her?
Yes.
No, she said you text her.
I texted everybody
You
saying,
don't- you don't-
no. I texted
You
everybody.
don't do that, Miss
I texted everybody saying, hey, the newsletter.
She gonna tell me to bring your A up. Then I'm say, yeah, man,
You know what?
she wanted me to do all the work.
I would too. It helps you learn.
Oh, do it.
So let's get logged in.
So you got it,
No,
bro.
it's your fault for not doing the
I should
work.
never gave you that paper. I feel like we even know a
Too big.
you gonna do it. You gonna do
He
it.
totally him on the face.
Oh, we just did this yesterday.
Just like.
Ah, man. I got
They been.
I don't give my
They
phone.
might- they did.
Which one's yours? 17?
Yes, sir.
I didn't take my
phone. Can I use my phone?
You think I'm kidding? I really,
I do whatever, condate, condate,
I hate for
whatever, long filter till one minute.
Or that why you like.
Alright.
But I lost my stroke.
Can I grab everyone's attention? I will write the code up
Oh, can
here.
I go to the restroom now?
I know how-
Be quick, we got something to learn.
They not like that.
So there's the code if you're still getting logged in. Everyone else, I need your attention up here. So what we are on is slide 7. Can you close that door behind you?
Ryan, you do.
Let me step outside for the internet, please.
No.
I need some internet.
Why?
Cause you ain't got no Wi-Fi in here, Miss Ken.
But you don't need it to look up your password.
No, I got the email mission. I just need to clarify it from my phone. Cause like I ain't got Wi-Fi here. I
Go
gotta verify.
by the
Hey, yo.
window. Alright,
Yes, man, bro.
eyes up here. So I want you to notice, look at this function. What function is this right here? Are we talking about?
Oh,
No. That
shit, what's his name?
square root.
How'd you know that?
We did it yesterday.
Not just that.
Yeah.
You see that parent function
Yeah.
sheet?
It's like,
We did it yesterday, didn't
That-
Okay, they did.
Okay,
They did
so
yesterday.
that square root is the square root
How would it
function.
know?
I also, hey, eyes up here. I want you to notice, look at the equation. What operation is there?
Oh.
Square root, right? This graph, this shape, is defined by that main operation. I want you to notice, the 0 is my input, right? What's the square root of 0?
0.
So if the input of 0 has an output of 0. I look here at the 1. What's the square root of 1?
1.
So the input of 1 has an output of
1.
1. What's the square root of 4?
4. No, hold on.
2.
2.
Oh,
So an input of 4 has an output of 2.
Oh, yeah.
I want you to notice, did we do the square root of 2? No, because do you know what the square root of 2 is? It's like 1.414 yada yada yada. Just can't, up here, okay?
Yeah.
What would be the next good input if we're talking about a square root?
Input is just,
Can you let Chase in?
wait, what was the question again?
The question is, right, so we have an input of 0,
Yeah.
an input of 1. I thought I heard you back.
Man, I'm not talking about bucket though.
Hey,
I ain't
zero,
got mine though.
y'all, eyes up here. Input of 0, input of 1, input of 4. What's the next square root?
No. Come on,
Square root of 9?
Oh, it was 9.
Because what's square root of 9? 3. And what were you saying? Square root of?
I forgot.
I thought you were gonna say 16.
I never heard that
16
before.
before.
Okay,
Hey,
hold on. Okay, hold on. Ryan, I'm teaching.
Pay attention, sir.
Come on.
You want to be a part of the whole class conversation? Cool, but
My bad,
like
kid, my bad.
up here.
My God.
So I want you to notice, like these points are not random. What is giving us these points?
The square root.
the square
The
root.
input and the output.
Those inputs and outputs, okay?
The x and the f of x.
Now, in slide 7, what are we doing to that function? We are multiplying by c.
See.
When we talked about geometric figures, we said multiplication is causing what transformations?
Compression and
Compression.
Compression and stretching, which are
Dilations.
What else can multiplication do? Remember, multiplying by a -1 causes a reflection. So what we're trying to do here is investigate if that is true. Pay attention to your value of C. Pay attention to where that operation is located, because remember, it could be either inside or outside the main operation. Pay attention to that. See how it's affecting the graph. Let's explore slide 7. We should be able to finish this pretty quickly. Answer the bolded questions.
Damn.
Let me show you how to do it. I got you. What the bold question is.
So are you using what same ideas we talked about in geometry? So multiplication by a -1 did what? Made it reflect?
Yeah, how did we- how did we-
So what about the other?
Dude, I'm going to hell on my mama.
Okay, look, remember y'all, we should be looking at this sheet, looking at the bolded questions.
Dude, you be wild with it.
Look at page, y'all, we should be looking at page 5, answering the bolded questions. And there's nothing that funny about those bolded questions. Come on. Get your password. It's a computer login. It doesn't have to be, it depends on what he said.
Oh, you should set your computer.
I barely.
Put your email in and do recover password and recover it before tomorrow. Because we'll use it again tomorrow.
Why does my, oh wait, I know why it shut off.
Because you haven't done anything on it?
No.
You over there hacking. Look, over there hacking.
How do I even act? Oh, how do I
You just have to, like,
act?
go-
Wait.
It's the same, it's that email account, and it's the same password to get onto the laptops. You go to office365.com and you log in that way. Come on, have we answered any of those questions?
I thought you got the link.
You know what, slide 7.
What is the,
Slide 7. No,
Oh,
you're right,
oh, slide 7?
slide 7.
No, I think all you just slide 7.
We're just on slide 7.
Hey, is it,
Huh?
is it actually 1:30?
Yeah, it says 1:30.
Alright, these computers work.
Okay, but how about the math that you're supposed to be
The
studying?
math, no time, math.
Like, it's not complicated. I need you to
Ain't
explore
about the
the.
time. Ain't talking about nothing but now.
Hey,
What do you mean, like, what you mean, like,
hey, instead
zero,
of
one,
putting
like,
just the
zero,
Y, you
point
put like.
That is a number between 0 and 1,
It's
yes.
11:30, you know, right?
So what's happening?
The blue one from
Ah,
X,
what's this?
intercept, well, as long as one is a little.
Cool, done.
What?
The x-intercept or the
I mean,
x?
the.
Remember, an
X-axis.
intercept, there, well, not x-axis.
What is it?
What is it, Jay?
Wait, I feel say,
It's the x value.
oh.
Because remember, the x-axis is only this line right here. That's the x-axis. Anytime you intersect the x-axis, that's an x-intercept. But that's the x value of that point.
So we switch.
C is less than 0.
No one switch.
Yeah.
Teachers and students, sorry for the interruption, we're getting ready to dismiss dismiss everyone by hallways to the gym or the theater. The 10th, 11th, and 12th graders are to report to the gymnasium. The 9th graders will report to the theater, so we can live stream it there. So this time, the 400 hallway,
You got him?
please start heading to.
Really quickly, just because we're gonna pick up here tomorrow, I wanna emphasize, hey, look, if that number is greater than 1, what happened?
Stretch.
We see a stretch. Now I need y'all to pay attention. Look, pause, I'll log you out of the computers. Look up here. Yes, it's stretched. Which direction did it stretch though? Horizontal or vertical? So vertical. Look, where is that operation? Inside or outside the main operation? It's outside. Does that confirm what we saw before with translations, that what's outside is vertical? That's a key idea. Have a good time at the Black History Month program. I will see y'all tomorrow. You didn't finish this? You need those first 5. Anything's better than a 0, I agree, but Jaden, this is the only thing out of here that I collected for the grade. That was not collected for the grade. That was to help you learn. You just gonna go ahead and go, oh yeah, I guess we said 400 hall. It's not just